Show of hands, who has used the Entity Debugger before? Okay, great, like 10 people. Don't worry, I'm going to provide enough information that you'll be able to follow along, even if you've never seen it before. Okay, so the problem that the Entity Debugger window solves came up when we first started making ECS, and that is that ECS produces data and stores it in an entirely separate place from regular Unity. So where normally you have all your stuff in game objects and components, ECS is a parallel world, basically. And so by default, the Unity editor can't show anything in that world, which means that if you haven't successfully set it up and you don't have anything rendering to the game view, you can't really see anything at all. There's nothing in the hierarchy, and that's not a good way of developing games. Another problem with ECS is that by default, an entity actually doesn't have any information associated with it. So with game objects, you've got a whole bunch of information, and that's actually part of the problem with game objects is they're fairly bloated. So by default, you have a name, you have layers and tags. You've got a transform on every single game object, which means you have a world position, scale. And a lot of things in games don't actually need all that information. So entities are actually just indices, and by default, there's no information associated with them. This means that it's kind of difficult to integrate entities and component data into the Unity editor as you might want to do initially. That's a project that is happening, and if you saw Joe's talk this morning, you saw a screenshot of the editor as it will or might look with support for ECS data. But that still requires having a bit of scaffolding there and guaranteeing that certain information is available so that entities can be displayed properly in the editor. So what we needed was some way of just showing data in ECS. And what we came up with is this window. And yeah, I'll just run you through it quickly. So on the left, we've got the system list. And this is the list of all systems that are running in your game. And as you know, in ECS, it's systems rather than components which provide behavior. You'll notice it's not in alphabetical order. It's actually in the order of the player loop, which is the actual order that these systems will execute every frame. And on the left, you've got a column of checkboxes, so you can turn systems on and off just for debugging. And on the right, we've got the main thread time, which is how much time each system has spent on the main thread. And that becomes less and less important of a metric as you start moving to jobs, but it's good to know that your systems are not on the main thread when they are using jobs. There's another control at the top there. There's a little menu. You can view different worlds. By default, there's just one world in ECS, but as you have a networked game or a number of other scenarios, you might want more than one world, and you want to be able to switch between these. And you can also show the entire player loop, that is, all the worlds, everything that executes, including built-in Unity systems, if you want, in that menu as well. That's usually far more information than you need, but it can be helpful if you're trying to finally schedule things in relation to the systems that we have. Okay, on the right at the top here, we've got a bit more information about the selected system, the full name, whether it's running, and we have a list of the queries or component groups that this system is using in order to get the data that it needs to operate on. And you can select those component groups. On the right-hand side of the component group list, you see the count number of entities that match each query. So this is just a screenshot from our voids demo. By default, we've got 50,000 voids, and then a couple of other things in the scene. and if you select a query, then you get the entity list at the bottom. This is the least interesting part of the window because, as I said before, entities don't actually have any data by default. So we can't guarantee that they have anything interesting to put in this list. If you select one of these entities here, you will be able to inspect all of its data in the inspector. But yeah, we can't guarantee that they have names or anything that makes them usefully identifiable. This is actually something I'd like to be able to let users define. That is something more useful to put into this list that you can optionally add to some component data, and that will be displayed there instead of just the entity indices. Okay, so I'm going to talk a bit about the query list, because that's where a lot of information gets displayed. Way back when we started with ECS, queries were really simple. And this is what the query list looked like. So it's just each query is a list of component types, and if an entity has those components, then it shows up in that query. Then, as time went on, queries got more complicated. We added read-write information to queries, so you can define whether you're just reading or also writing to a component. And we added support for subtractive queries, so you can say, I want these components, but not this component. And that started to get a little bit too complicated. This is the transform system, which admittedly is a complex system, but several months ago, this is what it looked like in the query list. And that's not something I want to read, and it's not something I want anybody else to have to read in order to figure out what's going on. But if we were to read it really quickly, just starting at the top left, we can see that the first query has a rotation, which is only reading from. It wants no heading because that's subtractive. Position is read-only, and so on and so on. So you can start to get a bit of a sense of what might be happening here. But obviously, we needed a better solution for displaying this information. So we came up with this colored styling. The colors are just to make it easier to see the little icons on the left of each pill, so the colors don't contain any unique information. But here we see them coding read-only, read-write in green, and subtractive in red. And instantly you can see a lot more information at a glance. You can see that the vast majority of components in this system's queries are subtractive. And that's because the transform system has a lot of queries which would overlap, and so it needs to subtract out components to make sure that queries don't overlap. So if you look at the first two lines, for instance, they're nearly identical, except for the transform matrix. The third pill there is subtractive in the first query and read-write in the second query. So those are complementary queries. They deal with almost the same data, but one wants a transform matrix and the other one doesn't. Also at a glance, you can see that the only things being written to here are transform matrices. And that makes sense because that's what the transform system does for the most part. So yeah, with a bit of styling and some color, we make this information that was technically there before a lot easier to read. And without knowing too much about it, you can get a sense of what's going on. Don't worry if you don't understand this, because the transform system, like I said, is one of our more complicated systems. It's just a good example of like when we're trying to make interfaces. If I can see anything useful about the transform system in a potential UI, then we're doing something right. This is what the transform system looks right now, and you'll see it's lost some color. The transform system got more complicated, and queries got more complicated. So the transform system now uses a chunk iteration API. And that's really useful when you don't want to express everything in queries. So actually the transform system is doing a lot more specific work, like the different groups of entities that it works on would probably fill at least 3 pages like this if they were expressed in the old query language. But yeah, the disadvantage of the new queries is that even though they're more expressive, they're a lot more difficult to just show on the screen. So yeah, this is something that still needs improvement. Basically, the UI needs to catch up to the underlying queries. So the reason it got more complicated is that we've added, in addition to just access modes and subtractive queries, you can do much more complex things, like you can say, I want all of these components, I want any one of these components, and I want none of these ones. And you can do that several times, so you can OR several queries together. And you can imagine how that would be more difficult to fit on a single line here. So, and the other thing then is that we're not showing access modes right now. And access modes are no longer encoded in queries, so that information is still in a system, but it's not exposed quite as clearly. So we need to do something there in order to bring that information like into the UI, make it accessible. And yeah, right now I'm leaning towards having different modes, being able to switch between different ways of displaying queries in order to be able to see all the data. Because obviously, like, this is complicated, but it is still very useful. This is not nearly as useful, and we'd like to get as much of that information there as possible. One more thing to note is that like, lists of component types are not the most friendly way of identifying anything, really. As the lists get longer, it almost doesn't matter how many colors you throw in there. It just gets hard to see like what a query actually is, what it means. And as you know, as has been repeated several times, it's systems which define behavior in ECS. But more specifically, it's the queries that a system makes which define the specific behavior for the results of those queries. So you might have 2 queries, and one provides input and the other one provides output. So you get different behavior from both of those groups of entities. I think it would be worth exploring asking developers to name their queries more usefully. So try and think about what the behavior is that you get from being part of this query. And that might be another piece of information that would be useful, not just to surface in this user interface, but when reading code, if you start thinking about things in terms of what actually happens to an entity when it matches this query and then a system processes it. I think in a lot of cases, that's something that you could express in the variable name. But yeah, that's also something that might not always be possible to express, and it's not something we can demand that everybody do just in order to have this user interface work. So we certainly want to have useful information there by default. Okay, one last bit of the UI, which I didn't show you before because I didn't want to scare you off, is the chunk info view. And this is new. I'm not quite sure if it's released yet. If not, it will be very soon. This is an extra bit on the right-hand side of the window that you can enable by clicking that button, chunk info in the top right. And this gives you additional information when you select a query about what matched that query. So in this case, in Boyd's, what you see is that there are 569 chunks that match the Boyd query. One archetype comprises all those chunks. And then we have a little histogram at the bottom It's not obvious that that's a histogram in this screenshot, but that shows how well used the chunks are, that is, how full they are. This is actually an example of ideal memory usage. So what the voids demo does is it creates 50,000 voids, and then it doesn't destroy any of them, it doesn't add any more. So on this histogram, you can see on the very far right, there's a spike indicating that 568 chunks are full. That is, they have the maximum number of entities in them that they can. And then there's one little blip down on the left, and that shows that there's one other chunk, the 569th chunk, that isn't quite full because 88 doesn't divide 50,000 properly. But this is an ideal scenario. This means you've got basically no memory fragmentation. I'll show you some other examples of the chunk info view can look like. This is from a few weeks ago in the Megacity demo. And here we have an archetype that, we've got 75,000 chunks matching from this archetype, but only 41,000 of them are full. And you've got various levels of fullness distributed across the bottom of that histogram. And yeah, that's probably improved. Part of it is just because of the way streaming works. We load worlds in parallel with the main world, and then we copy them in. So as you saw with the voids, there was that little one chunk that wasn't quite full. You get at least one of those from each world that you're copying in. So yeah, this isn't terrible. Down here, we've actually got very good usage. Just a few dots at the bottom of non-full chunks, but the vast majority of them are at capacity. And on the right here, we have a funny sort of worst case scenario. We have one chunk, and it's got one entity in it. That's the spike on the very left. And that, that's the worst case. If a chunk would be empty, then the chunk won't exist at all. So in this case, we're wasting a lot of memory. That said, this is the only option if you've got a singleton right now. So if you've only got one entity in an archetype, you don't really have a choice about this. I wouldn't worry about this scenario, even though it's not good memory usage. It's something that we're definitely interested in supporting better in the future. So singletons exist in every game, and we definitely want to be able to have those without wasting a bunch of memory. If you saw this same archetype and that same spike on the left, but it was, say, 50 or 100 chunks, then that would be a problem. That would mean that you've got a whole lot of wasted space, and probably those things could go together. Now, the most common reason for this is something that you're not able to see in this display. And this is something I've been trying to figure out as well. In an archetype, we store every entity in that archetype in a linked list of chunks. In this example, for instance, we've got the void sort of situation where they're mostly full except for the last one, which is almost full. But that's not the only thing which defines chunk structure. If you have a shared component data in your archetype, then the chunks are further divided by the unique values of those shared components. And that's really good for two reasons. One is that it means we don't duplicate data. We don't store shared component values over and over and over again when they're the same. And you get linear access for all same values of a given shared component. And that's super useful, for instance, with the instance mesh renderer, which, wants to render everything that has one mesh and then everything with the next mesh or material combination. So if you have shared component data, I think this thing might be dying. If you have shared component data, you might have two different values. So say instance mesh renderer with two different meshes would give you a layout like this. And if you were counting, we've actually added a chunk here just because there was, the odd space at the end. And the more unique values you get, the more fragmented your chunks get. And the worse your histogram will end up looking. And that's something that's sort of difficult to express in the UI because the thing that defines shared component data is really anything in that data. So in the case of instance mesh renderer, it's the mesh and the material. And if we were to make a list of all the different shared component values in order to actually show you what's going on, we'd have to show you all of the data in each of those components in order to split that up and show you the chunks properly. So that's another problem that I'm trying to solve and be able to show you really what's going on in memory without just pages and pages of identifiers. Because right now, as you can see, that single archetype at the top of the screen there is, it's just a list of component types, but it's pretty verbose. And once you start subdividing that by unique shared component data in order to really show the whole chunk structure, it will get harder to read. Okay, so that's an issue that we'd like to solve. Okay, I'm just going to summarize what I've talked about so far. We've got the Entity Debugger, which is a way of showing your data in ECS and lists your systems. You've got component groups in your queries, and you can get information about chunk memory utilization with the chunk info view. Shared component values are not really visible there, and that's an issue I'd like to fix. And finally, it's got kind of a weird name. I think considered changing it a few times because most of the time what you use it for is not debugging, but just viewing or exploring. And it seems like that might be a more appropriate name. But I've held off on changing it, and I'll show you why shortly. I'm going to talk about the future of the debugger, like things we've got in store. Just as an aside, you've heard that the Unity editor is going to be supporting ECS fully. Like you'll be able to use the editor as you do now with game objects, but with entities instead. And that's obviously a really important thing for not just artists and level designers, but for everybody using the editor. We certainly don't expect the Entity Debugger to replace any of the views that you're used to using. What the Entity Debugger represents is one of many possible new ways of looking at data which actually weren't possible before. So if I wanted to implement something like the Entity Debugger using game objects and components, it would, aside from the obvious mismatch in there not being systems in game object world, it would be a bunch of work and it would be slow in the end. There's no way around that. Whereas with ECS, we're leveraging the underlying architecture and it's very fast to get all this information. So it's a way of seeing your game and your game data and how your game operates that wasn't possible before. And this is really exciting to me. This is really just the first of a bunch of different possible things that we can do, showing your game data in ways that are useful and ways that are afforded by having that data laid out in a sensible manner in the first place. So one thing I'd really like to add, this is a picture of the frame debugger. If you're not familiar with it, it's another window we've had for quite a while now, which lets you look at all the draw calls in a frame, and you can walk through them, and in the background the game view updates, and you can see exactly what's happening, what's being sent to the graphics card. And for each of those draw calls, you can explore information about it. And the layout is quite similar to the Entity Debugger, and that's not a coincidence. Where here you've got a list of draw calls in the order that they happen, the Entity Debugger has a list of the systems in the order that they execute. And so one really cool and I think kind of obvious thing, well, once I thought of it, is to be able to step through your frame system by system and actually see what your data looks like at any given point in the frame. Or like, yeah, set up breakpoints in the editor so you can run and then once you hit a certain system, pause before it executes, step through it, see what happens on the other side. Maybe integration with like proper script debuggers at some point as well. Another really cool possibility here is once we've got support for determinism, you won't just be able to step through a frame, you'll actually be able to go back through the frame because we can just cache the data at the beginning of the frame and run through it to whatever point that you've selected. And this is how the frame debugger works right now. You can go backwards because it's, I mean, a frame is supposed to be finished in 16 milliseconds or 33 milliseconds, so it's not too hard to recompute part of it in order to show you the data in the state that you want. Okay, another thing we'd like to see is profiler integration, and this is something that's in the works already. This is just a picture of the profiler timeline view, and I know, because I know roughly how the Boyd system works, that on the top there, where you see Boyd system, that's the main thread part of the Boyd system. And then on the lower right, those 5 parallel blue lines are the jobs that are kicked off by the Boyd system. But at the moment, there's nothing in the timeline view that actually shows you that relationship. And that's a really important relationship for being able to figure out what's happening on your processor cores and what caused it. So we definitely want to make that relationship explicit and let you, explore it easily. And the other thing is that the Entity Debugger itself is where you see a lot of information about systems. But we'd like to be able to jump back and forth between the Entity Debugger and the profiler in order to relate the selected system to the appropriate bit of the timeline view. So this should make like a really tight loop for exploring what's happening every frame, how much time it's taking, and the relationship between all the parts and the various threads. So one other cool thing, and this is the next thing I'm going to be working on, is ECS really forces you to think about how your game is structured in a way that game objects and components didn't. And since we know exactly what's happening every frame and what order it happens in, what data gets touched by which systems, I think it would make a lot of sense to have a high-level overview of all of those things and all of the relationships between them. So there's a potentially very large graph here of all your systems, all the data that they touch, all the jobs that they kick off, and the dependencies between systems. And that would be a useful thing to visualize, and in some cases you might want to modify dependencies. So yeah, that's something that's coming. There's an obvious pitfall there, which is we don't want something like this, or we don't want to, give you way more information than you can actually deal with. So any reasonably complex game is going to start looking like this if we're not careful about filtering data and laying it out properly. So yeah, I promise I won't make you sift through something like this. One cool thing, though, is that once we've got stepping in the Entity Debugger, then you could have both these windows open at the same time. And as you advance through your frame, you can see like this system is executing, reads from here and here, writes over here, and then this system executes, and you can see the flow of your game, flow of data, how it's transformed throughout a frame. And what that means is we also have all the information to show you for a given value on a given component, we can tell you what affected this value, this frame. So you can trace it back, and if you're trying to debug something, you can see why this data is the way it is. And honestly, like, I'm really excited about being able to show that information. That's something that we couldn't really have dreamed of before, and that's actually possible now. Cool, yeah, so just a quick summary of the future, near future of Entity Debugger. Like stepping, being able to go through that player loop one step at a time, see actually what's happening every frame. We're going to have better profiler integration, so you can relate the Entity Debugger to the profiler view. And yeah, then this logic flow map, definitely not the final name, which gives you a top-level overview of your entire game and lets you explore the relationships between data and systems. Cool, so that's the talk. I realized when I was writing it that I don't have any documentation for the Entity Debugger, and I'm really sorry about that. I'm going to write some as soon as I get home. But yeah, questions are welcome, both now and there's a forum thread about it. And yeah, thanks very much for listening.